Hello and welcome to another Tune for Media lesson. It has been a while since my last video, and it's because I went to Bulgaria for a few weeks. But now I'm back. I'm back in my good old studio. And traveling Bulgaria, seeing all these landmarks and nature and cities and people and the Black Sea made me realize that I should really make a video about compressors. So, what is going on inside a compressor? I mean, literally, what is going on inside a compressor? We're all familiar with what it does. I mean, most people who are watching this video are probably pretty familiar with compressors, but how does it work? Well, we're going to make one from scratch today, and we're going to harness the powerful gen in order to make it. And in fact, every time you want to make something that should react fast and accurate with some degree of mathematic precision, gen is probably the way to go within the realm of max MSP. So we're going to make one from scratch, but before we begin, I must say a few disclaimers. The first one is that there are so many different algorithms and ways and approaches and equations to create a working compressor. And there are so many types of compressors that the one that I'm going to show you, it's not the compressor. So there isn't, the original kind of compressor. I'm just going to show you one approach, and it's based on the max MSP approach. They call it the hard way. And second disclaimer is that if you're familiar with my videos, you know that I'm not a professional mathematician, so I might get some of the terms wrong, and so sorry for that in advance. And okay, let's go. So we're gonna make everything inside gen, and I'm gonna try to explain all the steps in this compressor. And notice that I'm going to build a stereo compressor, because why not? So let's just get rid of this, and let's call our gen, let's add a title, and let's just call it compressor. Let's go here. So for now, just get rid of the grid. I don't like it. I tried it. Doesn't work for me. That's it. Okay. So right now, let's load up the code as well. It can be helpful sometimes. So right now we have just two ins equals to these two outs. So basically nothing is really happening. And like any good old compressor, is good to start with input gain. So we can bring our multiplier here, and because it's And because it's stereo, we're going to do doubled. Okay. So right now it's multiplied by default by 1. We're going to work with decibels in this compressor, because working in linear units like amplitude is very hard and it's not very efficient. So we're going to work with decibels. So decibels to amplitude, or dB to A. Can do this and hook it up like that. And for that, we can use param. Param is the way to make parameters talk to this gen object from outside gen. So you can also use inputs, but param is a good way. And let's name it input, and let's give it the minimum of minus 70, which is roughly 0 in amplitude, and maximum of 15 dB. Okay, and just hook it up like that. So now we should have, if we put a message of input, here you go, string 1, And let's put float box. Let's make a minimum of -70 and maximum of 15. And we should have a working gain. I know this is basic, but I want to cover some basic stuff within Gen in this lesson as well. So sorry for that, for those who are really deep into Gen. So let's call it input gain. And let's see if we have working gain. Good. So we have input gain. That's really nothing. So what is really going on with compressors? Basically, there's a lot of different algorithms, but you can sort of generalize that most compressors are sending a different signal from the original signal. Usually it's a measured loudness of the signal, and they take this signal and they do some different mathematical equations, and then they send the new gain to be multiplied with the actual signal. So this is that's pretty much the basics. So what we're going to do is, first of all, we're going to measure the loudness. And you can do it in two ways. You can use RMS, root mean square, and you can use absolute values, which is also known as peak values. And we're going to use peak values because it's a lot more reactive and it's simpler, and it's just putting this absolute object like that. And when it comes to root mean square, you should do some more fancy math because it should take some period of time to measure. So it's kind of different, and it's measure sort of like an average of loudness in a given time. So we send the two signals, the left and right, to this absolute. They will be combined together. And we are working with dB, so we should take this amplitude to dB. So this is my, it's called the gain computer. So basically calculating the loudness with an absolute value. And I think it is the XN in this case. Forgive me if I'm wrong. Okay. So the next step, and this is, I'm going to use the algorithm from the Max MSP example. They're sort of doing everything kind of backward. So they take this loudness meter, they take this measured loudness signal, and they put the larger than, the greater than, sorry. And so here we're going to put in the argument threshold. And of course, there isn't such a thing, threshold. We should make param for that. So name, you know what? Let me just copy that because it's almost the same. Threshold. And let's make it up to 6. So minus 70 dB is roughly 0 amplitude, and 6 is roughly 2. So it's like double the amplitude. So when you put the name here, threshold, is basically connecting them without this patch cord. So it's pretty good little extra in this Gen world. So let's put it like that. Okay, so so anything that is any signal that is reaching above the threshold will produce 1 from here, And anything that is below the threshold will produce 0. So you see that's a Boolean output, which means it's a true or false, or 0 or 1 output. And so we're basically creating some kind of a switch or a barrier for the threshold. So anything above threshold will produce 1, and signals that are below the threshold will produce 0. So let's go back to Max MSP and create another threshold. And so now that we have threshold, like minus 20. So what happened if I multiply this 0, 1 with my signal? Notice something interesting. It will create some kind of a nasty gate. And this is because that signals that are below the threshold, oops, come on. Okay, so this is because signals that are below the threshold will be multiplied by 0, or will produce 0, and the signal will be multiplied by 0. So it will cause silence. And anything that is above threshold will produce 1, so it will let the signal go through, and it will create some kind of a nasty gate sound, because we don't have any smoothing here and envelopes or something like that. So it's going to be very nasty. Let's see if we created this. Drop the threshold a little bit and you see that more is coming through. Everything. Pretty cool. Can be very musical. Okay, so obviously we can't use this threshold like that. What is going to be here is some kind of a reversed way of reducing the signal. So eventually we would like to multiply this 0, 1, this switch, with a number that will create the amount of gain that we want to reduce. And this amount of gain will eventually gonna be reverse subtract, and it's a resub, R sub. It's reverse subtraction of 1, which is unity gain. So this amount of gain will be eventually subtracted from unity gain, and then sent to this multiplication. So the number coming out from here will basically reduce the gain. So all that's left to do really is to figure out how to take another parameter, another very important parameter in compressors, which is the ratio, and calculate anything that is above the threshold according to the ratio, and subtract the gain from it. So first thing that we're going to do is we're going to create subtraction here, and we're going to subtract 2 inputs. So we're going to subtract the signal, the measured loudness, from the threshold. And I think in some places I saw it as overshoot. And if I'm wrong, sorry. So this is basically, it's a way to measure the amount of dB that is above threshold. So how much dB above threshold are we? So it's a good way of doing that. And we're going to create a reverse division of 1. So 1 divided by, let's create new param. Let's call it ratio. And with a minimum of 1, because you can't have 0, it doesn't make a lot of sense to divide by 0. and max of let's say 20. So, oops, forgot name. Okay, so the number coming up from here between 1 to 20 will be 1 divided by this number. And so let's create also this. Let's put 6, and also let's create minimum of 1 and maximum of 20. Okay, so we have 1 divided by this number, and we're going to multiply it by this overshoot, and it will basically give us the amount of compressed signal, sort of. I'll show you why in a second. Now we have to go back to amplitude units. So dB to A, decibels to amplitude. And now the amount coming up from here is basically reversed. So we have to subtract it from unity gain, and then multiplying it by the switch of the threshold. So it will eventually be 1 multiplied by something that need to decrease 1 to a lower number, and 0 will just make a 0, and then you subtract 1 from 0, nothing will happen, but 1 from, let's say, 0.65 will basically create the signal quieter. So to reverse it, we're going to do another reverse subtraction of 1, like that. And if we put it here, we should have a working compressor. So let's see. Not exactly. Let's see what something is something was left behind. Oh yeah, of course. So we also need to reverse this. Okay, so we definitely have a working compressor, but it sounds very trashy and sounds awful. And this is because it reacts so fast. The attack is basically 0. So it's so fast that it just sounds not good. It's very, very crashy. So of course, what's left to do is to create some kind of envelope for the compression, attack and release. So let's do that. So instead of immediately sending this amount to be reduced, we're going to do something. We're going to load up an object called slide. And the slide takes the number that from here and basically going in some amount of time measured in samples, and basically creating some kind of a slope. So it takes some time for the attack to kick in and then for the release to be released. And I think for that we should reverse it. So instead of doing a reverse subtraction, we're going to do +1 and basically multiply this one by -1 to create a negative value. So 1 plus a negative value will be the same, only it will react better with the slide. I think. Maybe I'm wrong. But we should try it. And I'm sending this here. And the slide should go here. And the slide is expecting time in samples. And the slide up is the release. So it can be a little bit confusing, but think about it. The release is when the unity gain is trying to recover. So you're coming from 0 point something to into 1, which is unity gain. And slide down is the attack, is the time that takes for the unity gain to drop in the number that is accepting from here. So it takes time in samples, and samples are really not very comfortable working. And I think milliseconds are a little bit more nicer. So what we're gonna do is we're gonna take the DSP state, and in gen is the sample rate. So this is actually outputting the current sample rate that we're using. So in this case, we're using, let's go to audio. So in this case, we're using a 44K. So this is the number that comes from here, like 44,100. And to calculate milliseconds out of it, you should multiply it by 0.001 or divided by 1,000. It's basically the same. Only multiplication, I think, is better and faster for computers than divisions. But anyway, maybe I'm wrong. So this is actually producing 44.1, and what's left to do is to create. Let's create 2 params, and they're going to be identical. So the first one, we're going to call it attack, and we're going to make a minimum of, let's say, like 0.5. Okay, and maximum of like 2,000. So this is milliseconds. Okay, and we're going to do another one, and we're going to call this release. And let's start the release by 5 milliseconds. And of course, you should play with the numbers, see what is working for you. So we're taking this number, the 44.1 in this case, and I could write just 44.1, but I want it to be dynamic. So let's say if I'm loading up a patch, a parent patch that is on 96K, so I want it to change accordingly. So milliseconds will be true milliseconds. So all that's left to do is to multiply the number coming up from here with this number, and do it twice, one for the attack, one for the release. And so this is the release. It's going to be in the slide up, like we said, and this one is going to be in the slide down. And now we can introduce 2 more controls. Okay, and release. So I should have also a working attack and release. And let's also put this minimum so it will be more fun to play with. Minimum, maximum, like that. And we said that the release is from 5 to 2 seconds. And let's see if it works. Very trashy. So the attack is really fast. Even bring up the ratio. Bring the attack to like 25. Ooh, a lot punchier. Okay, so we definitely have a working compressor. I think playing with the numbers and trying to get maybe different ways of smoothing the envelope, or even trying different algorithms, can create maybe better or more specific sounding, or maybe even trying to model an analog version of like a legendary compressor or some type. I think all of this, exploring all of this can really make you learn how to create incredible tools. So let's make one last touch just for fun. Well, we're going to add another output. This is the amount of gain that needs to be reduced. So I can take this gain, and if I put something like meter, oops, not mer, meter, I should get a gain reduction meter. Of course, I can also add, can also take this entire thing and add also, it's a little bit crowded here, but you get my point. Can add some makeup gain, and we can call this makeup. So if we take this, we basically have a fully functional studio compressor. Makeup, and we just basically have just a makeup gain. So doing something like that. Alright, so I hope you liked this video and learned something from this video. And I feel like it's really, really exciting to learn how these incredibly fundamental and basic and important effects like compressor, how it works. And if you like this video, please subscribe for more, and see you next time. Stay tuned.